Hello friends, I welcome you in lecture number 14 on exponential distribution. In this lecture also we will discuss two more problems on exponential distribution. And before solving those two problems, we just recall that if a random variable capital X follows an exponential distribution with rate parameter lambda, where lambda is nothing but average number of events per unit of time, then CDF of this exponential random variable is given by fx equal to 1 minus e raised to minus lambda x, and we know that this CDF is defined as probability that capital X is less than or equal to small x, and mean of this exponential random variable is related to this parameter lambda by mu equal to 1 divided by lambda. So sometimes they are giving the value of rate parameter in the question. Sometimes they are not giving lambda, but they are providing the mean of exponential distribution. So using this formula we can obtain the value of lambda, which is required in the CDF as well as in the PDF of exponential distribution. So with this in our mind, we try to solve this problem first. The time between failures of a machine is exponentially distributed with a mean of 4 hours. Find the probability that a failure, that is failure of machine, occurs between 2 and 5 hours from now. So here they have already specified that you have to use exponential distribution, and they have given that this time between failures of a machine is exponential random variable. So we consider capital X equal to time between failures of a machine, and the probability we have to calculate is in units of hours. So here we consider this time in hours. If they ask to find the probability in minutes, then here we would have taken time in minutes. So that we will take care. And what is another thing given? It is given that this time between failures is exponentially distributed with a mean of 4 hours. That means we are given the mean time between failures of a machine. So we are given the value of mean of x, that we denote by mu, and that is equal to 4 hours. So using the formula lambda equal to 1 by mu, we can find out value of lambda 1 by 4, that is 0.25. So what is this lambda? Lambda is the average number of events per unit of time. Here lambda will be average number of failures per hour, and once we have value of lambda, we can write the CDF. Therefore the CDF of capital X is fx equal to 1 minus e raised to minus lambda x, and that means fx equal to 1 minus e raised to minus 0.25 into x. So we put value of lambda in the formula of CDF, and we obtain this CDF for this particular problem. And the probability we have to calculate is that a failure occurs between 2 and 5 hours. The failure of a machine occurs between 2 and 5 hours. That is equivalent to the fact that time between failures is 2 and 5 hours. So we have to calculate the probability that this time between failures is between 2 and 5. That is, we have to calculate this probability that 2 less than x less than 5. So now we write that probability that machine failure machine failure occurs between 2 and 5 hours, that is equal to probability that time x between failures of a machine is between 2 and 5. And we know that this capital X is continuous random variable, so if we are writing equality or inequality, it does not matter. So I can rewrite this as probability that 2 less than or equal to x less than or equal to 5. Why? Because if x is continuous random variable, then probability at a single point is always 0 if capital X is continuous random variable. That means probability of x equal to 2 and probability of x equal to 5 both are 0. And this I can rewrite as probability that capital X less than or equal to 5 minus probability that capital X is less than or equal to 2. So we are interested in the probability between 2 and 5. So first we are calculating probability up to 5, that is probability from minus infinity to 5. But we require probability for this interval only, so we have to subtract this part, probability of x less than or equal to 2. And by the definition of CDF, this is equal to f of 5 and this is equal to f of 2. And now we are having CDF, it is 1 minus e raised to minus 0.5 into x. Let me write here also. Fx for this random variable is 1 minus e raised to minus 0.5 into x. So first we put x equal to 5 to write down f of 5, and it is 1 minus e raised to minus 0.25 into 5 minus for f of 2 we put x equal to 2 here. So it is e raised to minus 0.25 into 2, and if we simplify this, 1 will get cancelled, and this quantity e raised to minus 25 into 5 is equal to e raised to minus 1.25, and here we will get negative negative positive, and this is 0.25 into 2 is e raised to minus 0.5. And using scientific calculator up to 4 decimal places, this I obtained as minus 0.2865 plus 0.6065, and this value is 0.3200 or 0.32. So this is the probability of machine failure occurs between 2 and 5 hours. Probability that time between machine failures is between 2 and 5 hours is 0.32. If you wish, you can calculate this same probability using PDF also. If you are not comfortable with CDF, you can write first, you can write lambda into e raised to minus lambda x. Lambda is 0.25, so here I will write e raised to minus 0.25x, and this is for x non-negative. For x negative it is 0. And if we want to calculate the probability that x lies between 2 and 5 using PDF, then by the definition of PDF, this is equal to integration of PDF between 2 and 5. So here you can integrate between 2 and 5, x is always greater than 0, so we can put f of x equal to 0.25 and 2 e raised to minus 25x dx, and then you can integrate. Integration is easy. This is going to be e raised to minus 0.25x divided by minus 0.25, that will get cancelled with this, and we will be left with minus e raised to minus 0.25 into x, and this is equal to minus e raised to minus 0.25 into 5 minus minus plus upper limit minus lower limit, and here we have minus 0.25 into 2, and this is same as our calculations using CDF. Okay, we obtain the same answer here also. Okay, this is 0.2865 and this is 0.6065 and this is equal to 0.32. So that is your choice, either you use PDF or CDF, you will get the same answer. Okay, fine. Now we move towards the next problem. Here it is given that a light bulb has an average lifetime of 1000 hours. What is the probability that the bulb will last more than 1200 hours? So first we define our random variable. We will consider capital X equal to lifetime of a bulb. Okay, they are talking about the lifetime of a bulb, and the probability we have to calculate is in units of hours. So here we consider capital X equal to lifetime of a bulb in hours, and we are given average lifetime of 1000 hours. That is, we are given the value of mean of X, given that mu equal to 1000. So using this we can find out lambda. So we know that lambda equal to 1 divided by mu, and this is 1 divided by 1000, that is 0.001. So this is the lambda, and once we have lambda we can write down the CDF, or first we have to write that we are using exponential random variable or we are using exponential distribution. So here we mention that here X is following exponential distribution with lambda equal to 0.001. They have not specified here that you have to use exponential distribution, but we know that whenever we are discussing the time until some specific event occurs or time between successive events, then we are using exponential distribution with parameter lambda. So once we have parameter lambda, we can write the CDF of X. The CDF of X is fx equal to 1 minus e raised to minus lambda x, and that is 1 minus e raised to minus 0.001 into x. Now they have asked to calculate the probability that the bulb will last more than 1200 hours. So this is true if lifetime of a bulb is more than 1200 hours. If lifetime of a bulb is more than 1200 hours, then we can say that the bulb will last more than 1200 hours. So now we are writing whatever probability is required. They have asked to calculate the probability that bulb will last more than 1200 hours. This is equivalent to the fact that lifetime of a bulb is more than 1200 hours. These two are equivalent statements, and lifetime of a bulb we have denoted by capital X. So we have to calculate the probability that capital X is greater than 1200, and that we can rewrite as 1 minus probability that capital X is less than or equal to 1200. These two events are complement of each other. Therefore, probability of this event equal to 1 minus probability of complement of this event. And this is nothing but f of 1200. Using the definition of CDF, we know that fx is nothing but probability that capital X is less than or equal to x. And we have the formula for fx in this problem. Our fx is 1 minus e raised to minus 0.001 into x, and we are interested in the value at x equal to 1200. So here we put minus 0.001 into 1200, and if we open this bracket, 1 will get cancelled and negative negative positive, and this product becomes minus 1.2. and using scientific calculator I find that this is equal to 0.3012 up to 4 decimal places. So this is also very easy problem. What we are given the average lifetime of a bulb in hours. Using that average lifetime, that is value of mean, we obtain the value of parameter lambda, and once we have lambda, we can use the formula of CDF to calculate the required probability. And we have to understand this type of equivalency of statements. Here we are asked to calculate the probability that bulb will last more than 1200 hours. That is equivalent to the fact that lifetime of a bulb is more than 1200 hours. So we must be able to write down equivalent statements in this way, so that we can convert required probability in terms of our random variable, and then we can use the appropriate formula of CDF. So this is all about this session. I hope you like it. Thanks for watching.